Hey, how's it going, everybody? Welcome back. Today on Milanese Math, we're going to be taking a look at line graphs. And as always, if you want to follow along with this worksheet, you can find it at the first link in the description below. Okay, so we just got done with a section about bar graphs, and those are good for showing data that are in different categories. Line graphs, on the other hand, are good for showing change over time. So you see this all the time in like a business report, or how much your sales are changing, or how your bank account is changing over time. And most times you'll see that used with a line graph. So let's take a look at the first chart and let's use it to answer numbers 1 through 5. As always, take a second, make sure you know what that graph is showing you. So the name of this graph there at the top, it says produce sales. Looks like on the x-axis I have the different months, and on the y-axis I have the sales in thousands of dollars. Okay, so let's see if we can answer some simple questions based on that. Number 1, what month did they have the least sales? Okay, in other words, if we track that line graph, where does it dip the lowest? When did that happen? I think that would be all the way down here in March. So March was when we saw the least number of sales. The opposite of that, the most sales, in other words, when it peaked at the highest, looks like it's all the way that very last month in June. Okay, let's try another one. How about number 2? Between which 2 months did sales increase the least? So make sure you understand what that's asking. They're looking for from one month to the next where there is an increase, but it's the smallest amount of increase. So we want to see that line going uphill, but we don't want it to be very steep. And as I glance at that, I think I noticed that between December to January, because check that out. That is an increase, right? Like if I trace that line, it is going uphill, but just barely compared to January or February, which is a lot steeper. So yeah, I think the answer to our question is between December and January. How about number 3? Which months had more sales than February? There's a lot of ways you could kind of answer this question, but if I look at the sales that came in February, right, something like that. So this point right here is February. Which months had sales above that line? In other words, which months were there more sales? In other words, they would be higher up on the y-axis. Well, that would be this one, and this one, and this one. So I guess that was what? November, May, and June. So November, May, and June. Cool. All right, how about number 4? How many more sales were made in November than October? Okay, so if you kind of glance at that, I think we need to get 2 numbers. For October, looks like what, about 35, somewhere around in there. And then in November, what was that number? Somewhere between 60 and 70, let's just call it 65. Okay, so it went from 35 to 65, and they're asking how many more sales were that? Well, if you do the subtraction problem, 65 minus 35, that's going to be about 30. Keep in mind though, this scale is in thousands, so it's really $30,000 difference. That's much different than 30. So that's why it's always important to pay attention to the y-axis. Okay, how about number 5? It says, by what percent did sales increase from October to November? We just did a couple videos ago, we did a little series on percentages. And when we talked about percent increase or decrease, we got the following formula. And so what you want to do is find the difference between the 2 numbers, divide it by whatever the original number was, and then multiply that by 100 to get it to turn into a percentage. So it says, by what percent did the increase from October to November? Well, we just did that in the previous problem, right? We know that the difference is 30,000, okay? So the difference from month to month was 30,000. But what was the original amount? Where were we back in October? Well, it was at 35,000. So sales were at $35,000 and they went up to 65. So that's a difference of 30. If you multiply that by 100 after you're done dividing, that turns out to be an 86% increase in sales. That would be huge. I mean, if you were a company, you would want to know that just in that month alone, you increased your sales by 86%. That's huge. Okay. Now, Let's flip over and look at the next graph, and this is going to help us answer numbers 6 through 10. This is a double line graph, okay? So in other words, it's the same X and Y axis for both, but it's just tracking two sets of information. And in this case, it looks like it's two separate schools. Looks like school 1 is the yellow line and school 2 is the blue line. Well, what is this measuring? Well, I can see on the X axis that they're talking about years, and it's a number of first graders on the Y axis. Okay, so let's take a look at this and see if we can answer some tricky questions. Number 6 says, which school had more first graders in 2017? Okay, so if I go down here and I look at 2017 and I track up, I've got the blue line here, and then higher than that is the yellow line, and it asks which one has more first graders. Well, clearly the yellow dot is higher up on the scale, so that would be school number 1. Okay. How about number 7? It says, how many more first graders were in school 1 in 2013 than 2012? Okay, so school 1 is the yellow, and they want to know basically if you're going from 2013, which was here, from 2012 to 2013. Okay, so what are those numbers? Well, if you trace over to the y-axis, you can see that in 2012, looks like we had 34 first graders, but then in 2013, it bumped up to 40. Now, the question they were saying is, how many more are there in 2013? Well, if it went from 34 to 40, that would be an increase of 6 students, and all I did was subtract those numbers. Okay, how about number 8? It says, by what percent did school number 1's enrollment increase from 2012 to 2013? So this question is a lot like number 5, right, where we have to take the difference divided by the original and multiply it by 100. Luckily, we've already done this, or part of it at least, on number 7. We've already found the difference in enrollment between those 2 years. It was 6. That was our answer to number 7. Now, we have to divide that by the original, and there was originally in 2012, there were 34 students. So if we take 6 divided by 34 and multiply that by 100, we're going to get 18%. So there was an 18% increase in students at school 1 from 2012 to 2013. Number 9 is kind of an easy question if you know how to read the graph. It says, what year did both schools have equal enrollment? Well, if you trace those lines, they crisscross in a few places, but the only place where they have a data point in common is right there, and that just so happens to be 2018. Okay, I think we can do number 10, and then I think that's going to call it for us. So it says, number 10 says, which school saw no change in enrollment from 2014 to 2015? So think what that would look like. Your x-axis obviously is going to continue from one year to the next, but we don't want there to be any change in height, or the y-axis, right? Because there's no change in the number of students. So which school saw no change from 2014, which is right here, to 2015? Well, it looks like right here, this yellow line just stays flat, right? So their enrollment stayed the same. And which school is the yellow line? Well, that again is school number 1. Okay? So if you have downloaded this worksheet, you'll notice that there's a whole second page that has some other good questions for you. So hopefully this video was helpful, and if it was, consider subscribing to the channel. And as always, thanks for watching, and we'll catch you next time.